We're solving problem 17 from the 2024 AMC 12B. Integers a and b are randomly chosen without replacement from the sets of integers with absolute value not exceeding 10. What is the probability that the polynomial x cubed plus ax squared plus bx plus 6 has three distinct integer roots? So for this problem, we can apply Vieta's formulas. So we get that, well, first, we see that the set of integers with absolute value not exceeding 10. So that means a and b greater than or equal to negative 10, but less than or equal to positive 10. So in this set, we have 21 possibilities for a or b. Now we do 21 because we have to include the 0 in it. And when you count from 1 to 10, that's 10 integers. And likewise, from negative 1 to negative 10, you need to include the 0. So now we have that the number of total possibility of pairs is 21 times 21 minus 1, because one of the a or b has already taken one number. So 21 times 20 is 420 possible pairs. Then for our Vieta's formulas, we get that x1 times x2 times x3 is equal to negative 6. We get that, oh I know this is plus. We get that x1 times x2 times x3 negative a. Then we get that x1 times x2 plus x2 times x3 plus x1 times x3 is equal to b. Then we can consider the number of roots or values for a and b. So 1 roots x1, x2, x3. This is case 1 is equal to negative 1, comma 1, comma 6. Now when we check here, what we're basically checking is if these align. So in this case, we would want these types of values. So like what we basically do, we can calculate the values of a and b to make sure they work. So what we ideally want is that b is negative and a would be positive. So we can see that this one clearly works. Just put a check to it. You can solve it yourself. x1, x2, and x3. Next set is going to be 1, 2, negative 3. Check it again. It works. 3, x1, x2, and x3 is 1, negative 2, 3. This one works again. X for x2, x3 is negative 1, 2, and 3. This one works again when you check it. And on case number 5, x1, x2, and x3, they're all negative. So b here, in this case, if you solve for it using this formula, would be not in our desired number. So not in our desired range, because we'd want them in this sort of range. That's what we're checking for. And we see here that b does not work. And we see that we've actually exhausted all of our possible options. So we see that we only have 4 possible combinations of roots, and that's pretty fantastic on itself, because we only have 4, and now we can calculate the probability. So it would be total number of outcomes that are good, which is 4, over total number of outcomes, or pairs in this case, which is 420. 4 over 420 is 1 over 105. So that is our answer, and that is pretty fantastic.